My dear students, welcome to the subject of statistics for the class 12th English medium, the first part, third chapter, linear regression. And today I will be teaching you four important theories from this chapter. The first theory, coefficient of determination. Now till now in this chapter we have studied about how to find a regression line or the best fit line or the best fitted line of regression using the scatter diagram and the least square methods. But we have discussed in the previous chapter that the correlation measure describes the relationship between two correlated variables, and then using the regression we can estimate value of a dependent variable based on the value of independent variable. So what does coefficient of determination do? Coefficient of determination is the measure of the strength of the two variables. We know that regression function relation between two correlated variables, and it is useful to estimate the value of dependent variable for the given value of independent variable, and the determination measures the reliability of an estimate. Now it is natural that if two variables are perfectly correlated, their estimate will be perfect. What if these variables are not perfectly correlated? At that time we need some measure of estimate using which we can think, okay, we can estimate that 50% reliability is there or 60% reliability is there, or certain measure will give us an answer with 80% accuracy. So you can say that this reliability is the measure of accuracy with which we can estimate the value. Okay, so whenever we are going forward with something, we need that estimate beforehand, that okay, if I am doing this I will be successful by this much percentages, or what are my chances of achieving something. So this measure of coefficient of determination is something like this, which gives us the measure of reliability or the measure of accuracy of an estimate. Now suppose the regression line is y cap is equal to a plus bx, then the square of the correlation coefficient, mark my words, it is very easy, just square of the correlation coefficient, that is r, gives us the coefficient of determination. Simple r square, small r square, which is denoted as capital R square. As you can see here, coefficient of determination denoted by capital R square is the correlation coefficient between original value and the observed value, estimated value, that is the observed value and the estimated value, correlation coefficient between these two values and its square, that is coefficient of determination. Now you might be wondering, sir, you haven't taught us how to find the correlation coefficient between actual value and the observed value. Look at the step here. Observed, that is the actual value, is just y, while y cap is a plus bx. Now remember the property of correlation coefficient, it is independent of the change of origin and scale. Means whether you add or whether you multiply something or deduct or divide something with the x, the answer is not going to change. That means rather than writing a plus bx, we can write x, and if we can write yx, correlation coefficient says that xy means the same thing. Therefore capital R square is the small r square. Now my dear students, you don't need to actually remember this step. Just remember, to find the coefficient of determination you have to square the correlation coefficient which you studied in the second chapter. Just remember this, forget everything else. Now this is the piece of property which I just explained you guys, that independent of change of origin and scale, therefore we have taken x instead of a plus bx. This is just for the sake of knowledge. Remember, coefficient of determination is capital R square, which is the square of simple correlation coefficient which we studied in the second chapter. That's all done. Now R is either positive 1 or negative 1 or something in between. Now when we square the value, negative 1 becomes the positive 1 and positive 1 remains the positive 1. So capital R square's maximum value is 1, because small r square can be negative 1 or positive 1, nothing more than that. So capital R square can be maximum 1. So when we can say that there is a perfect positive or perfect negative correlation, we can say that there is a perfect relationship between those two variables. Therefore, capital R square will be 1. And that means that the estimate of y obtained from the regression line are 100% reliable. When capital R square is 1, the estimate is 100% reliable. But if R is 0, when R is 0, we say there is no linear correlation between two variables. That means capital R square will be 0 and there is no linear correlation. So estimate obtained from Y for the regression line are not reliable. So here the value of capital R square is between 0 to positive 1. The minimum value is 0 where it is not reliable at all, 0% chances of reliability, and 1 that is the 100% chances of reliability, and anything in between these two. Once again, if the value is more than 0.5, it has higher degree of reliability. If the value is less than 0.5, it has a lower degree of reliability. This is how you are going to solve this particular thing. We are not going to do it sum right now in this tutorial, but at a later date I will be doing sums of this method. Right now I am only going to explain you some theories in this tutorial. The next theory in line is the properties of regression coefficient. Now this is the theory I haven't explained you beforehand, but there wasn't any need, as this measure is just a copy of the correlation coefficient kind of thing, and these properties are very easy. The first property, that the signs of R and B, that is correlation coefficient and regression coefficient, are either positive or negative, means they are same. If R is positive, B will be positive. If B is negative, R will be negative. Why? You see this formula here, B is equal to R into Sy upon Sx. Now Sy and Sx are standard deviations and they are always positive. Means the remaining measure R, if R is positive, your answer will be positive, and if R is negative, your answer will be negative. So thus we can say that B and R, regression and correlation coefficients, both have the same signs, either positive or negative. The second, regression coefficient is independent of change of origin but not independent of change of scales. Now you should remember this change of origin, change of scale thing. I have explained you guys a lot of times. Change of origin means adding and subtracting, while change of scale means multiplying, dividing. We know that correlation coefficient R is independent of both of them. We could add, subtract, divide, multiply, our answer will not change. But as you know, we have discussed it in the shortcut method itself, that when we add or subtract something as a UV, there is no change in the answer. So BYX will be BVU, both will be same. But if we multiply or divide U and V, we have to write CY upon CX, else our answer will be different. That means regression coefficient doesn't care about addition, subtraction, but it does care about multiplication and division. That means it is not independent of change of scale. The last note, this is one of the most IMP notes. This is the regression line of y on x always passes through the point y bar and x bar, that is x bar y bar. Remember this because so many times in board papers, MCQ and 1 mark question based on this particular line of note has been asked. So remember this, write it down using IMP mark in your notebooks. This particular theory, you have to write all these theories down in your notebook once, and then if possible try to write it down without looking at the tutorial another time in your homework notebooks. That way you will remember this. These theories have been asked and students lose their marks because they don't pay attention to these theories. Next is the utility of the study of regression. Here the utility means the use or the importance or something like this. So the utilities of regression, number one, we can determine a functional relationship. You know, my dear friends, whenever we talk about statistics, we have to talk about the functions. Statistics is all about estimation and analyzing and probability, and for that we need a function. So just saying that two variables are closely related or not closely related or linearly correlated is not enough. We need to show a functional relationship between those two variables to find answers, and for that purpose regression provides us with a function. So that's the utility, that it determines a functional relationship between two correlated variables. The second one, that once a functional relation is established, it uses the best thing in the world, predicts the future. It predicts the unknown value of the dependent variable y on the basis of known value of independent variable x. Everyone wants to predict, everyone wants to estimate the future, which this regression can do based on the numbers. Third one, we can determine the approximate change in the value of dependent variable for a unit change in the value of independent variable x. For example, we have the data of rainfall and the yield of wheat. I want to determine that with 1 centimeter increase in the rainfall, how many more tons of wheat production can I get? This is enabled through regression only. Using our B regression coefficient, we can determine that 1 unit change in rainfall will bring how many units of change in the production of wheat. You can use that particular relationship for any two variables. So using regression, we can determine this thing. Fourth one, we can determine the error in estimation. Our estimations are never foolproof. We do make mistakes in the estimations, and using the regression we can actually find the error in our own estimation, that what are the errors, what are the difference between the observed and the estimated values of a same variable. So that regression helps us in doing this. Regression is very useful for economists, planner, businessmen, administrator, researchers. Basically, regression is useful for commerce. Whether you are doing a business, whether you are a statistician, an accountant, an analytical study student, doesn't matter. You need regression for everything. The last theory always, it ends with the precautions. We know that regression is quite useful, but we should be aware of its precautions. We can't just take regression as a god power. It doesn't estimate everything with 100% accuracy. That's why we have the coefficient of determination here. So before using regression, we need to check or verify using the coefficient of determination. So before actually estimating, we should check whether our regression is efficient or not using the R square formula. If we think no, it is 70, 80, 90, 100% accurate, then we can move forward. But if by finding the R square we think that no, it is only 20% or 30% or so accurate, we should just ignore the data. So precaution, the first precaution is that we should estimate only after ascertaining the linearity of regression by the coefficient of determination. Beware guys. The second one, regression relation obtained by the scatter diagram or the method of least square should not be used for the values which are very far from the given values. Let us take an example. For example, you took a data of price and demand. The price was 5, 10, 15, 20, 30, and after using this data you suddenly wanted to check or estimate the demand when price is 100 rupees. Once again, 5, 10, 15, 20, 30 was the data and you wanted to estimate for 100 rupees. So naturally your original data and the data for what you want to estimate have a big difference, and the regression doesn't work that way. The value which you want to estimate should be very much near or from between the data itself. If you take a very far away or a very distant value, your estimate will be wrong and you will make a mistake. So that's the main precaution here. The example given here is about the rainfall and the yield. That for example, you created a regression line for a certain data of a rainfall, and then suddenly you wanted to estimate yield for a very high rainfall. Naturally, when there is over amount of rainfall, the yield doesn't increase, it diminishes as the yield is destroyed with the flood. So we can't estimate such kind of data for a far off value. So that's a very important precaution. My dear friends, thus our theoretical portion ends today, and I also end my tutorial here. Next time I will be discussing some of the important illustrations based on coefficient of determination and the properties of the regression. Be very careful about these theories. Statistics is a calculative subject, no doubt. Theories are boring, again, no doubt, but they are helpful in gaining good marks. So, whatever theory I am explaining here, don't forget them. Keep on revising. Stay home, stay safe. See you soon, my dear friends.